Okay, for number one, it says solve for x where x is a real number, and they give me an equation, and it does look difficult, and I'll be honest with you, I did have a tough time getting through this problem. All right, so let's go to the whiteboard, write the problem down, and I'll tell you what I eventually saw in the problem. This is number one, but anyway, this will be a different number when you see it. I do see the root 3. I see minus 1. I see sine of x plus root 3. I see a plus 1, and I see cosine of x, and I see 4 root 2. Now granted, one thing I do see is I see a root 3 and a root 2 in the problem, and I do recognize they have something to do with triangles that I'm familiar with. 60, root 3, 2, 1, and the 45, 45, 90, 1, 1, root 2. All right, so what I want to do is talk about the sine of 60 degrees and the cosine of 60 degrees. The sine of 60 degrees is root 3 over 2, and the cosine of 60 is just going to be 1 over 2. You could also write down the sine of 30 degrees is going to be 1/2, and the cosine of 30 degrees is going to be root 3 over 2. That's one thing you recognize. Other thing I recognize, sine of 45 degrees is the same thing as a cosine of 45 degrees. And was that going to be 1 over root 2? I am seeing those numbers, by the way. So the first thing I did was I divided both sides by 2. And you're going to get root 3 over 2 minus 1/2. I do recognize that numbers now. The sine of x plus root 3 over 2 plus 1/2, and then cosine x. And that's going to be now 2 root 2. All right, I divided both sides by 2, by the way. And let me, continue along writing these things down. And the first thing I see is, root 3 over 2, I could write it as the sine of 60 degrees. And then 1/2 I could write down as a cosine of 60 degrees. And that's going to be 2, whoops, not 2, I didn't divide that. That's, let me get my eraser out. Oops, get rid of that. I got to pay attention, right? Sine x. And then plus sine 60. And then plus cosine 60. That's degrees, by the way, over cosine of x. And that's going to be 2 root 2. Next thing I'll do is to multiply both sides by the LCD. And the LCD is going to be sine x cosine x. All right, let me do that. What are you going to get? It's tough even jamming all this stuff in over here. And minus cosine 60 degrees. Now, if you multiply the first term by sine cosine, the sine would disappear. You get cosine x. Let's do the next term. It's going to be sine 60 plus cosine 60. It's 60 degrees. I know I sine 60. And the cosine disappears. You're left with sine. And then what do you get over here? You get 2 root 2 sine x cosine x. All right? All right, I'm going to keep moving along. I'm going to expand this thing out. And it's going to be sine 60 degrees cosine x. I'm distributing this across these two terms. Minus cosine 60 degrees cosine x. I'm going to distribute this across that now. What do you get over here? Plus sine 60 sine x plus cosine 60 sine x. And that equals 2 root 2 sine x cosine x. All right? Okay. Here comes the trouble now. And this is where I kind of struggle with saying, where is this leading to? And, some things it does lead. I'll be honest with you. I'm seeing some things over here. I want to point out I'm seeing this pairing as something I know about. All right, so I'm going to write this down over here. I'm going to put down sine 60 degrees, cosine x, and then the last term is going to be plus cosine 60 sine of x. All right? Now, these are what I want to write down now. So it's minus cosine 60 cosine x plus sine 60 sine x. I do recognize that, by the way. And this equals 2 root 2 sine x cosine x, all right? So by recognizing something, I want to rewrite that, all right? And then I'm hoping that things are going to come into place over here. So let's write the first guy down, sine 60 cosine x plus cosine 60 sine x. All right, let me go back over here, minus, and I recognize this thing as being, let's take a look at that. That's cosine 60 degrees minus x. And that's going to be 2 root 2 sine x cosine x. By the way, I'm also recognizing this. All right, let's write that one down. And what's that going to be? That's going to be the sine of 60 degrees plus x minus, that's going to be, let's take a look at that, the cosine 60 degrees minus x. And that's going to be 2 root 2 sine x cosine x. Wow, this is problematic, isn't it? And let me take a look at this one over here. And let me take a, I gotta be careful too, you know? Let's see how we do with this one over here. Oh, you know what? I made a mistake. I just see it. And let me write this. I got to clear this up too, by the way. That's actually a minus sign there. So I have to correct this over here to be plus now. And this to be plus. All right? All right. I definitely am seeing something there. All right? All right, I'm going to move forward. And where am I going to move forward to? I'm looking at this thing. I wonder what to do now. I do notice another identity, by the way. I'll write this over here. Sine 60 degrees plus x minus the cosine 60 degrees plus x. That's kind of promising, by the way. And then I'm going to say, I notice a root 2. So what I'm going to do is divide both sides by root 2. And you're going to get 2 sine x cosine x, which I recognize being sine of 2x. All right, I'm going to look at this now and wonder what to write down. And I'm going to write this over here. I'm going to write down the sine of 45 degrees, that's 1 over root 2, by the way, times the sine of 60 degrees plus x minus, I'm going to write down the cosine of 45 degrees times the cosine of 60 degrees plus x equals the sine of 2x. Okay, I recognize the sum again. Let me tell you what I recognize over here. That this is minus cosine 45 degrees cosine 60 degrees plus x minus the sine of 45 degrees times the sine of 60 degrees plus x. And that's a sine of 2x. It's going to be minus. All right, let's take a look at this one over here. And that's going to be the addition of those two. So it's going to be cosine of 105 degrees plus x. All right, let me make sure that's true. 105 degrees plus x is equal to the sine of 2x. All right, it'd be nice if both sides were sines, by the way. And I'm going to rewrite this as minus the cosine. Nope, not the cosine. I'm going to write cosine again. I want to get it in terms of sines. And I use a cofunction identity that the cosine of theta is going to be the same thing as the sine of 90 degrees minus theta. All right? So let me write this over here. So the cosine is going to be sine. And what do you get there? It's going to be 90 degrees. Let's see, minus 105 degrees minus x. Well, that's going to be minus 15 degrees minus x. And write that down. Minus 15 degrees minus x equals sine of 2x. Well, I'm going to use an even-odd identity, that the sine of minus theta would be minus sine of theta. Make sure that's true, by the way. F of theta, I know it's an odd function, right? F of theta would be minus f of minus theta. Whoops, let me put a plus sign here or there instead. Yeah, I can write this down now. So sine, and I'll double check that, by the way. Minus f of minus theta is f of theta. Yeah, that's what I have. So it's going to be 15 degrees plus x. That's the opposite of that angle. Is going to be the sine of 2x. All right. So let me just make sure I'm in a clean area at this point. And I'm going to say there's a trivial answer to this right by looking at it. When does 15 degrees plus x, when is it identical to 2x? And that's when x is 15 degrees. All right? Again, we go back and check it if you like. But I want to point out, there's other solutions too, by the way, and this repeats itself. I know that much. But anyway, I want to point out, looking at this over here, let me write this over here, that the sine, we're actually trying to solve this equation over here, 2x equals sine of 15 degrees plus x. All right? And I'm going to have repeating solutions in the problem, by the way. But in general, the sine of A equals the sine of B. In general, I can say A is equal to B plus 2 pi k, or I could say pi minus A, that's a reference in the second quadrant, would equal B plus, you know what, I'm using degrees and now I'm talking radian. I shouldn't do that. Let me just erase and go back to speaking degrees. I'll go back to radians later, by the way. So A equals B plus 360 degree K, and then the other one's going to be, or it's going to be 180 degrees minus A, that's the reference in the second quadrant, by the way, would be B plus 360 degree K, all right? With the understanding that K is some integer value, any integer, by the way. So let's write this down. I'm going to put this one down first, and it doesn't look that bad, by the way. You get 2x, and the B is 15 degrees plus x plus 360 degree K. And what do you get there? You get x equals 15 degrees plus 360 degree K. And that worked out pretty nicely, by the way. It's one I expected. I expected the 15 degrees, but I'm expecting it's also repeating itself. Now this one's going to be more of a challenge for me. Let me write this one down for you. So 180 degrees minus A, which is 2x, is going to be equal to B, which is 15 degrees plus x plus 360 degree K. It's more of a challenge for me. So let me write this one down for you. And what do you get? Let's take a look at that. You get minus 3x, and then you get minus 165. I'm taking 180 from both sides, plus 360 degree K. I'm going to divide both sides by minus 3. You get x equals, that would be 55 degrees minus, I'm doing 3 into 360 now, it's 120, right? All right, this one's going to produce more answers, by the way. This one keeps coming back on itself, but this 120, you know, it's going to cycle until you hit 360. So I'm going to take k to be 0. What are you going to get? X is 55 degrees. By the way, it'll repeat itself every 360 degree K. All right? Let's take K to be minus 1. What do you get over there? And again, I got to be careful with the arithmetic over here. And that's going to give me 175 degrees if K is minus 1. Let me hit 120. Yeah, 175 plus 360 degree K. All right, let's do K to be minus 2 now. Once I hit 3, I'm out of the range, by the way. I'm at the 360 mark. Let's take a look at that one. That's going to be 240 and 55, which is 295. Okay? I got my 4 answers, by the way. Let's write them down now. X equals, let me make sure I'm saying it right, 15 degrees plus 360 degree K. Let's put the next one down. That's going to be 55 degrees plus 360 degree K. The next one's going to be 175 degrees plus 360 degree K. And the last one's going to be 295 degrees plus 360 degree K. By the way, I should probably speak in radian, and let me go through that. So 15 degrees times pi over 180 degrees would be pi over 12. So I'm going to write this as pi over 12. Let's see, plus 360 is 2 pi, right? All right, let's do the other one, 55 times pi over 180 degrees. Let's see, 5 goes into 55 11 times, and 5 goes into 180 36 times. So this is going to be 11 pi over 36 plus 2 pi k. You know, I'm going to write this in terms of 36s, by the way. So it's 3 pi over 36 plus 2 pi k. Let's do the next one. 175 times pi over 180 degrees. And I got to simplify that too. And what's that going to be? Let's do 5 again. 5 would give me 36. And 5 into 175. Let's see, 3. That gives me 15. 25 is 5. So 35 pi over 36 plus 2 pi k. Wow, these are tough, aren't they? That's a k. Let's do the last one. 295 times pi over 180 equals, I'm going to divide by 5 again. So 5 goes into 295. Let's see, 5, that's 25, and then 45 and 9. So 59 pi over 36. Write that down for you. 59 pi over 36 plus 2 pi k. I think we did okay. This is the final answer, by the way. All right? I'm always a doubting Thomas, so in the notes what I'll do, at least in the answer key, I'll post a graph of it, making sure that those solutions are hitting it periodically. Thank you.